Hello, welcome to this YouTube video. In this video, I'll be explaining the implementation of different functions of linked lists. The very first thing I do, I include the standard input library so that I can use the printf and scanf functions. Then I also include the standard library for memory allocation and other dynamic operations. Now 9.7, I create a structure node that takes in an integer number and then also a structure pointer that points to the next node. And then these are the different function prototypes that I'm supposed to implement. They have to create a node, I have to print the list, I have to append to that list, and then I also have to delete by key, delete by value, and then insert after key and also insert after value. Now in my main function, first I create a structure that points to null, and then it will take into arguments where I'll have a trace and then also the data that I'll be implementing. So in this function here, the while, this is what is going to be displayed on the screen, and these are the options we are either going to pick. We can either pick the first option where we are going to print the list that we have, or the second option where we append to that list, or the third option where we append to that list. We can also delete a value from that list and then also exit the list. So here, this is where the switching happens. This is where we ask the user to select a choice that they want. In case one, they can just print the list and then it breaks so that any other function won't run. And then the case two, we ask the user to enter a value to append. We store it using the scanf, and then we append it to the list. And then case 3, we also ask the user to prepend a value. We store the location of the value using this and then prepend it. And then case 4, we ask the user if they want to delete anything. So yes, we still store the location and the data that the user has input, and then after that we delete it. And by default here, if any user enters any other case, either 6 or 7, we just print invalid input. So these are the different functions. Uh, we have creating a node. We use this function of a structure node, and then we allocate memory of that size of that node. And then the very first part of the node will point to a number, and then the second part of the node points to next, which is supposed to be the next node, but in our case, we are creating the very first node, so it points to null. And then in print list, this other function, we use void so that we can only implement them when we call for them. Here, the structure node points to the head, which is the very first node. And then if we are printing and then we print the very first node, it works like this, where if it's not the very first node, it goes on to the next one, stores the location, and then returns it using this function, and then also points to the next one. So if we have a very first node, it will go to and print the data, but then also print to the next one that takes it to the second node until all the nodes are done, and that's how we print our data. And then if we want to append, we still create a node using this function, and then we check if the head is equal to null. The new node we have created should point to the head, and then we return. And then if not, if the very first node is not equal to null, and then we take the node we have created and it should point to next, and then next becomes our new node, and that's how we append to the list. And then append to the list, it will keep on looping through until the very last node, and then add in the new one that you want to create. But for prepend, we are only inserting a value that takes on the very first position. So we still create a node, and then we first check if our new node is equal to next, and then we it should point to the head, and then the head should point to that new node that you have created. Now, if you want to delete a value, for this case, it's only the first one that we check for when we want to prepend. That's in adding the node, adding a value in the very first place. And then if you want to delete by key, here we still create a node that points to head and then also points to the very previous one. And then this if function checks if temp is not equal to null and temp number is not equal to key. That temp should point to next, which should become our very first head, and then we free the one that we want to delete. And if it's not the case where it's going to loop through, it will check the first one. If it's not equal to that, this is deleting by key. And then until the key that we want to delete, that's when this one will break out. Or else if any other condition comes up that's unexpected, we're just being careful here in this function. And then deleting by value, here a value that you've entered and then you want to delete it. So we are going to first check if still we get a structure node, another that points to the head, and then another that points to the previous value, which is equal to null. So you first check if the very first node is equal to null. If that's the case, there's nothing to delete, so we go to the while option. But then if we have something to delete, we first check if it's not equal to null, and then we store the value, and then we remove the pointer, and then point to the next one, and then we free that node, and that's how we remove that value. And then when we want to insert after a key, same story, we first create our node and then check if it's pointing to the head, and then if it's not equal to null, we store that key, and then the one we want to insert should point to where that key is, but then after next to it. That's the code that is implemented here. And if the very first one is equal to null, that means that we're just going to return, and then the new node you are going to create, it's going to be the very first one. And then inserting after value. In the case where you've entered a value into a node of a linked list, for example 10, and then you want to add another value right after the 10. So it's going to check, it's going to search value using this. And then when we find that value, we get the next part where it's supposed to point to the next link, and then this next one should point to that node that we are supposed to create. And this is how the code should work. So I was running it before. Let me first abort, and then let me build and run again. So for the very first case, this is what is displayed. We are asking us if we want to print a list, if we want to append, prepend, delete, or exit. So first we want to append to our list, so I'll select the second option and then add any value. Let me add 20 and then enter. Then I also still want to append to it, so let me select the second choice. And this time let me append 40. Now let me print and see what has happened. Now for printing, you press 1, then enter. So we can see that we first appended 20. Appending adds to the end of the list. So our first value we entered was 20, and then the next value we entered was 40. And then if I want to prepend, that's adding the very first to the very first part of the list. I'll select the third option, and then it's asking me to enter a value that I want to enter. I want to enter 10, and then it has accepted it. So if I'm to print my list again, I can see that now 10 has been prepended to the list, and it's the starting. So we have 10, 20, and then 40. So if I want to delete a value, now this time my choice will be 4, which is delete. And then I enter the value that I want to delete. In this case, I want to delete 20. So I enter 20. And then it has accepted it. So now I'm going to go ahead and print my list again. select